Alright, this video is just going to be a video of selected homework problems from today's assignment with the solutions. That's all this is. So fast forward through to the problems that you want. Not all of them are worked, but this will give you a good sampling. Okay, numbers 19 and 20 in your book were already done for you, but there's an error in them. So what we'll do is we'll just work them correctly, and then you can see where the error is. Alright, so on number 19, we have 1 plus tangent x, 1 plus cotangent of negative x. And remember that cotangent is an odd function, so this would actually be 1 plus tangent x, 1 minus cotangent x. And that's where the error is in the book. So if you multiply all of this out using, the FOIL method or whatever, so you'd have 1 minus cotangent x plus tangent x minus tangent x cotangent x. Well, tangent is sine over cosine, and cotangent is cosine over sine. So if you multiply those two together, you just get 1. So I have a 1 here minus a 1 here, so I'm going to end up with negative cotangent x plus tangent x. And that's it. You're done. Okay, on number 20, same kind of deal. Secant is an even function, so this is just 1 plus secant theta. And I'm just rewriting the problem without the minus signs in them. And so both tangent and sine are negative, so this is negative sine minus tangent. And then to solve this, you're going to go ahead and change everything to sines and cosines and get a common denominator. So for instance, on top, in the numerator, I would have 1 plus 1 over cosine. The common denominator there is cosine, right? So then in the denominator, I would have factor out a negative, and I would have sine theta over 1 plus sine over cosine, because that is tangent over there. All right, so the common denominator in the bottom is also cosine. So let me add that to the top and the bottom. Okay, in the numerator, what I'm going to have is I'm going to have cosine theta plus 1 all over cosine theta. And then in the denominator, I'm going to have negative sine theta cosine theta plus sine theta. I'm going to run out of room over cosine theta. And then when I take the reciprocal of the denominator and multiply, I'm going to end up with cosine theta plus 1 over negative sine theta cosine theta plus 1. This one cancels with this, and I'm left with negative 1 over sine theta, which is negative cosecant theta. And I believe that is your answer. Okay, on number 27, this is the problem. And I'm going to work with the left side. I'm going to work with this side over here. And I'm going to make it look like secant. So to give myself a little bit of a head start, I'm going to go ahead and write it like this. This is theta, sorry, and then cosine theta. Just so I can see what I'm headed towards. Now, this is a even function on the top, so I'm going to have the cosine of theta on the top and 1 minus sine theta on the bottom, because sine is an odd function. Anytime I see 1 minus or 1 plus, I'm going to do my trick where I multiply by the conjugate of the denominator. Right, just a form of 1. This is just a form of 1 right here, just a form of 1. And then when I multiply this together, I'm going to get 1 minus sine squared in the denominator, which is really what I needed. So I have cosine 1 plus sine. I'm not going to multiply it through because I just have to factor it out. Sine squared theta. Well, I know from the Pythagorean identity 1 minus sine squared is cosine squared. So I have cosine theta, 1 plus sine theta over cosine squared theta. I can cancel the cosine with one of the cosines in the denominator. And I am left with 1 plus sine theta over cosine theta. If I write them as separate fractions, like I see up here, then I would have 1 over cosine theta plus sine theta over cosine theta, which is secant theta, plus tangent theta. And I'm done. All right, take a deep breath. This looks kind of interesting. It looks like you might want to do the left side until you think, not sure what I would multiply times. So I think what I'm going to do instead is work on the right side over here, okay, the tangent. And the first thing I want to do is convert everything to sines and cosines, being very careful to maintain the angles, x and y. So, for instance, over here, I'll go ahead and do blue. Tangent of x is sine x over cosine x plus sine y over cosine y. Tangent x is sine x over cosine x. And tangent y is sine y over cosine y. All right, and all I did was convert all these tangents to sine and cosine. All right, in the numerator, I'll draw that big line. In the numerator, the common denominator is cosine x, cosine y. All right, the first fraction already had a sine x, and then in the denominator it needs the cosine y. The second one already had a sine y, and it needs a cosine x. In the denominator, the common denominator is going to be cosine x, cosine y, which if you'll notice is the same denominator in the numerator, which means it's going to cancel. And then over here I just had a 1, so I'm going to put the whole denominator, cosine x, cosine y, minus sine x, sine y, right? Because this one over here was already done. This here, you can see if I just put that over itself, it turns to 1. If I put this one over, it's this. So that's where I found it. Up here, if I write this and make a cosine y here, this one's missing a cosine x, and then you can see how I got to it over here. All right, now, to do fractions, we do it just like we've been doing it. You flip and multiply. So I have sine x cosine y plus sine y cosine x over cosine x cosine y times cosine x cosine y over cosine x cosine y minus sine x sine y. I'm going to cancel those two things, and I'm basically left with this, which is sine x cosine y plus sine y cosine x all over cosine x cosine y minus sine x sine y. And I'm done. Whew. This is another interesting one. You can see that I've got here a fraction plus a fraction equal to 0. So remember that when you verify an identity, you don't move anything across the equal sign. So I'm obviously going to have to deal with the left side. It's the more complicated. And I need a common denominator because these are two fractions added together. And the easiest way to find a common denominator is just to multiply the two denominators together. All right, so that's what I'm going to do. The common denominator is going to be sine x plus sine y times cosine x plus cosine y. All right, so I'm looking here, up here. This one is missing a cosine x, cosine y, right? And this one up here is missing a sine x plus sine y. Now, I don't know if you realize, but that's going to be, wait, this is a plus, the difference of two squares. So for this top part, I could actually multiply these two things together, and I would end up getting cosine squared x minus cosine squared y. And then over here, I would get sine squared x minus sine squared y. Now, here's an interesting thing. If I just reorganize these a little bit, do you see that I've got cosine squared x plus sine squared x? And I know that is going to be, hopefully you know this, right? And then this one right here, both are negative. So I'm going to factor out a negative, and I'm going to have cosine squared y plus sine squared y. And that's all over the same denominator. And I'm going to write it just for clarity. But I have to tell you, it's hard to do that. All right, so cosine x plus cosine y. Got it. All right. Now, this right here is just 1. Do you see that this right here is also 1? What is 1 minus 1? 0. So 0 equals 0, and I'm done. That's it. Okay, I believe this is the last one, and this is number 39, 2 secant squared x minus 2 secant squared x sine squared x minus sine squared x minus cosine squared x equals 1. Okay, so let's do a little bit of analysis here. From the last problem that we just worked, if I factor out the negative, I have what? Sine squared x plus cosine squared x. This little piece that I have underlined is a negative this. This is going to be what? Negative 1. So this whole thing right here is negative 1. So let's rewrite it. I have 2 secant squared x minus 2 secant squared x sine squared x minus 1 equals 1. Do not move anything across the equal sign. Okay? So if I'm looking at this right here, just this part right here, I know that secant is, so I've got negative 2, secant is 1 over cosine squared. Oops, hold on. Yeah, x. I'm going to do x. X. And then I have sine squared x in the top, right? So isn't that negative 2 tangent x? So let's write this. I've got negative 1, negative 2 tangent squared x. Well, now let's look at this one right here. Do you see that that's secant? Well, secant is 1 plus tangent squared x. So I would have 2 plus 2 tangent squared x. All right? So I have 2 tangent squared x minus tangent squared x, that's 0. And then I have 2 minus 1, which is 1. 1 equals 1, and I'm done. So there were a lot of substitution there, but that's that problem. Okay, that's all I'm going to work from this one. You may have some additional questions. Bring those to class, and we will do them then.